Hello student, welcome to the next class. So in this case, I will be explaining one more problem on the analysis of a non-concurrent force system. So the question is given, a bracket is subjected to three forces and a couple as shown in figure. Determine the magnitude, direction and the line of action of the resultant. That means we have to calculate the R value. Direction is nothing but theta value, and the line of action of resultant is nothing but the distance of line of action of force of resultant with respect to the any specified point. So I'll denote as a D point, or you can write x intercept or y intercept. Okay, either you can, if you calculate these are the simple, or we can calculate easily. Okay, so this is your A, B and C. So we'll calculate with respect to A point. Okay, so in this case the forces are given, which is of 200 Newton acting upward. There's a force of 100 Newton, I think it's a 400 Newton, sorry, so 400 Newton, and there's a 150 Newton force, and there's a one couple which is of 50 Newton meter. Okay, so first thing what you have to do is those forcing making certain angle, you have to resolve in an x component and the y component. If I do that for this force, first I'll draw the x and y component of this force. So what will be the y component? It will be 150 sine of 30 degree, because if I resolve along the y axis, so it will be away from the angle. So 150 sine 30. If I resolve the x component, it will be 150 cos of 30 degree. Similarly, in this case, if I resolve the force in x and y direction, so it will be 400 sine of 45 degree and 400 cos of 45 degree. For the calculation of the R, so we can first calculate the summation of fx. So for the calculation of summation of x is, which is nothing but sum of all the horizontal forces. So in this case, how many horizontal forces we have? 1, 2, 400 cos 45 and 150 cos 30. So both are acting towards the left side direction. So it will be minus 400 cos of 45 degree minus 150 cos of 30 degree. So if I calculate, then I'll get the summation of fx equal to minus 412.7. So next is calculation of summation of fy. Summation of fy is nothing but sum of all the vertical forces. How many vertical forces we have in this problem? 200, 400 sine 45, 150 sine 30. So three forces. So 200 is acting upward, so positive 200. 400 sine 45 is acting upward, that is also positive. Then 150 sine 30 is acting downward, so minus 150 sine 30 degree. So if I calculate, then I'll get value as 407.8 Newton. Okay, this is the value what we'll get for the summation of x and the summation of fy. Then we can calculate the R by using the formula square root of summation of fx square plus summation of fy square. So we'll get the R value. So R will be equal to 412.7 square minus plus 407.8 square. If I calculate, then R will be equal to 580.2 Newton. So this is the magnitude of the resultant. Then the direction can be calculated, theta value, by using the formula theta is equal to tan inverse of summation of fy divided by summation of fx. So the tan inverse will be equal to summation of fy, what we are getting is 407.8, whereas summation of fx will be 412.7. so the theta value will be equal to we'll get 44.66 degree. So this is the theta value. Next we have to calculate the d value. So for the calculation of the d, we need to apply the Warrington principle, which said that summation of movement, sum of all the movements at a particular point will be equal to the movement due to the resultant mr. So which is nothing but summation of ma equal to r into d. So with the help of this we can calculate the d value. So for the calculation of d, first we should calculate the summation of ma. Already we have the r value, so with the use of that we can calculate the d. So summation of ma can be calculated, summation of ma equal to, so that means taking the moment of all the forces about a point. Okay, so at this point we have to take it. So how many forces we have? 1 2 3 4 5 forces, and there's one couple. So start with the first force, which is of 200 Newton. The line of action of force passing through the movement center, movement due to that force will be 0. Next come to the second force, which is 400 cos 45. The line of action of force is this, and the perpendicular distance is this, which is nothing but 0.6 meter, and it will create a clockwise movement. If it is a clockwise movement, then I'll write positive value. So 400 cos of 45 degree into the distance is 0.6. Now come to the second force, which is third force, which is 400 sin 45. The line of action of force is this, and the perpendicular distance is 3 meter, and it will create anti-clockwise movement. If it is anti-clockwise movement, then minus 400 sin 45 into 3 meter. Now come to the your movement, which is clockwise direction, so directly I'll write a moment value which is of 50 Newton meter. Then come to this force. The line of action of force is this, and the perpendicular distance is 1 meter. Okay, so it will create again anti-clockwise moment. So minus 150 cos 30 into the distance as a 1 meter. Now come to the next force, which is 150 sin 30. The line of action of force is this, and the perpendicular distance is this, which is 3 plus 3, 6 meter, and this will create again an anti-clockwise movement. So it will be minus 150 sin 30 into 6 meter. So if I calculate the summation of ma, so I'll get summation of ma as minus 388.3 Newton meter. So that means movement due to all these forces will create a negative movement, which is an anti-clockwise movement. So the r into d, the resultant and the perpendicular distance to the resultant with respect to a point also should produce this same anti-clockwise movement. So now d can be calculated by substituting the value into the above equation, which is I'll write only the value, not my sign. Okay, 388.3 equal to r is how much? 580.2 into the d distance. So d value what we'll get is 388.3 divided by 580.2. So d value what we'll get is 0.660. Okay, these are the d value. Now the very important aspect is representation of your resultant force in the diagram. So this also carries some mass, so don't forget to show your representation of resultant in your given diagram. So this is the given diagram. So this is your A point, this is B point and C point. With respect to A point, we need to show it. So as we know that the resultant what we got is the summation of fx is negative and the summation of fy is positive. That means it will lies in a second quadrant. That means the force will be like this direction. Either force will be in this direction or away from that. Okay. So if I consider this as the resultant correct value, then it will produce a clockwise movement, but the movement what we are getting is anti-clockwise. That means the resultant should be produce the anti-clockwise. So this is a correct. So I'll wrap this part, and this is your d value, and this is your resultant, which is a 580, and the distance is 0.660, and the r value is 580.8, 80.2. This is the representation. One more thing, even you can calculate the x and y intercept. So x and y intercept is easily calculated by using the formula with this diagram itself. You can see that x and y intercept is nothing but this is your x intercept, this is your y intercept with the use of your values itself. So your x can be written as a x is equal to d by sine theta, which is nothing but d is 0.660, theta is 44.66, so sine 44.66, so we'll get as a 0.938. Similarly, if I calculate y, which is d cos theta, so equal to 0.66 divided by cos of 44.60, so we'll get certain value. I think I have not calculated. Okay, I'll get 0.92. These are the x and y intercept.